All right, guys, let's go ahead and begin our tech talk on what's new in NX for manufacturing 2506. All right, so your questions will be answered live at the end, but feel free to go ahead and enter them into the chat as we go through the session. Our presenter today is Yehia. He is located in our Cincinnati office, and he has over 7 years experience in aero engine manufacturing industries, specifically in the CAM and CNC machining. And throughout his career, he's worked as a CNC machinist, a CAM programmer, and of course a manufacturing engineer. So he is a valid expert. We're happy he's here. All right, welcome Yehia. The Tech Talk is now yours.
Hello all, thanks for joining today. We'll be talking in this tech talk what's new in NX 2506 for the manufacturing, and there are a ton of enhancements that has been made to this version. So without further ado, let's go ahead and take a look at those enhancements. So starting with the applications and the architecture, there is a new addition in the NX CAM, which is App Hub. So basically, in the Post Hub, we do have an option called the application. So it has been extracted and uh, set a separate application hub here. So the NX CAM hub is a powerful addition to the Siemens NX ecosystem. So a centralized cloud-based marketplace designed to enhance the programming efficiency. So basically, it offers a wide selection of modular and third-party applications that expands the capabilities and address specific manufacturing needs. So all the applications are fully compatible with the latest NXCAM releases, ensuring you are always working with reliable, up-to-date tools. So thanks to our rapid release cycle, you'll gain immediate access to the latest features, keeping your operations agile and competitive. So let's go ahead to the NX and take a look at the NXCAM application. It's basically, like I said, a cloud-based environment where it also has a lot of third-party applications, including the Siemens developed application as well as the other vendors. So when you launch the NX 2506, you will be seeing a App Hub icon over here, and then when you browse application on App Hub, similar to the Post Hub, it will ask for the credentials to log in. It would basically be your GTAG credentials. So once you have that, and then you need to enter those credentials, and then you can log into it. So as I said, you can find all the applications over here, and this also helps us to install all these application in a in a single click, where you can directly say, let's say for an instance, if I download the NXCAM split hole machining, I can directly see that application is installed right away on my App Hub ribbon bar. So with this, you can avoid those installation steps. All the applications, what you see over here has a download option, can be downloaded and installed with the same with a single click. So there are also some other third party applications available for those you need to purchase it. These are basically from the vendors. So that's the App Hub, and it's a pretty useful tool for all the applications that are available inside the NX. So now coming to the NX CAM's machine powered programming, let's start with the big picture. In the NX CAM, the redefining what's possible in manufacturing programming. Siemens is moving away from the traditional manual methods towards an intelligent integrated approach that aligns with the demands of modern production. It's basically not just an upgrade, but it's a whole new way of working. So if we take a look at the mission power programming enhancements, there has been a new enhancement where NX gives users unprecedented control and visibility over their machine operations with the ability to view and adjust the current machine access values of the active machine. User can fine-tune operation in real time, ensuring precise adjustments at any point during the process. So if we look at our NX, so if I select any of the single operation, usually before to get to access this machine access, we need to be in the in the simulation environment. Whereas in the NX 2406 release, it's directly available outside of the simulation environment. So you can access it from the machine tab over here. And when you hit the show machine access, it will be available, and you can like as you saw inside the simulation environment, you can dock and undock this dialog box over here. So if I go ahead and animate this toolpath, you will see the real-time access movements inside the machine access positioning. So let's say if I wanted to see whether my tool that I'm currently using uh, can be reduced from its length, I can go further down to my Z and see, okay, so if I go this down, there may be a chance of collision to the part. So in this way, you can really see the differences of what tool length to be used right away in the process of your NC programming. So this is basically a seamless integration that that will help you to enhance the decision making and helps optimize the machining performance. Okay, so now coming to the collision detection and the toolpath verification. Another key advantage of machine powered programming is optimizing toolpath to avoid collisions. With the display tool in the machine feature, user can visually preview the machines. As you already aware of it, this has been released in 2406. This allows for early detection of potential collisions. However, there's still a risk of missing hidden collisions. So to mitigate this, we introduced the check toolpath for machine collision feature. This tool thoroughly checks programmed toolpaths against machine collisions, automatically capturing and listing the detected collisions. So if I again go back to my annex over here, let me close this. And if you check the toolpath option in previous version, you will only be seeing the gout check, collision check, and the collision check against part and the IPW. Whereas there has been a new enhancement called machine collision, where you can directly select the group of programs or a single operation and check if there is any machine collisions towards that operation. So as I said, this will help you to, so since I do not have any collisions here, it's not showing up here, but if I force a collision, let me go ahead and create a collision over here. So if I did my tool, I'll go ahead and reduce my shank length so that it, I can force it to a collision over here. So let me go ahead and generate this. All right, so if I now go ahead and check the toolpath with the machine collision uh, couching checked on. So now instead of simulating the entire program, you can directly see the machine collision right away at which area the collision is happening. So if you see, it has started from here and it has ended from here. So it will give you a notification, a visual representation saying that this part of your tool path is getting actually collided with the machine. So that's a very helpful tool, I would say. And let's take a look at the graphical tool interaction. So simplified tool commissioning with the direct interaction. The commissioning tools in an XCAM can often be a cumbersome process, especially when dealing with complex setups that involve numerous tools and carriers. Traditionally, users interact with the operation navigator or the machine setup configurator, but adjustments to the tools and devices, especially when relocating them, can be a challenging task. So, finding the right tool in these interfaces often requires navigating through a clustered list, which can be frustrating and time consuming. So, let me show you an example of that. Okay, so here I do have an MPP kit. So usually in the previous version, all these tool related activities are being controlled inside the operation navigator in the machine tool view. But whereas in the latest versions, machine setup configurator has been taken over that responsibility. Uh, but if you see over here, especially when you're working with the huge carriers where you have two different wheels with hundreds of tools, it is basically a very hectic process to select individual tool in that list when the list is too big. But whereas in the NX2506 version, if you navigate to the machine tab over here, you can select the tools or devices where once you select, the selection filter will be changed to the component. And if I hover onto this tools inside this magazine, if you see on the left side in the machine setup configurator, all the pockets are getting expanded. This will help if you have a very huge list of tools and that tool list is like out of your scrolling area, and you can even directly select here the tool and say unmount or edit it, and it will disassemble the specific tool from that pocket, and that tool will be placed under the assignable option. So you can even drag the same tool and drop it to the same pocket number. Again, that tool will get assigned to the pocket 7. So there are lot of good enhancements in this specific category, which helps user to navigate through the tools and the devices effectively with these helpful UI options. Now, coming to the next topic, we have improved tool holder classification. The tool holders plays a critical role in both the CAM setup and on the mission itself, and they require a specific workflow for proper creation and use. In the past, the classification systems like device or head were too vague to be effective, especially for the machine powered programming setups. With the introduction of the new tool holder classification, we are significantly improving the user experience. So if I go to my NX and let me show you an example here. So this classification for the holders, let me open a new file where you can add a tool holder component, and in the machine tool builder you can see the newly added tool holder classification. So inside the machine tool application, uh, if you right click on this empty no name, where if you can insert, previously we do not have these many of component classification available, but for now, whereas in NX 2506 you can add the tool holder base component, you can directly specify the body, and you can also specify the mounting junction like accordingly, and then you can directly save it to the library. And once you have saved it, you can directly import it from the library to your current manufacturing session. So it it should have a child component from the tool holder base. So as you say here, we have two different mounting junction. One, the bottom mounting junction is for the turret, and the top mounting junction, what you see over here, is for the capto tool that you place on this tool holder base. So by defining all these specifications and the classifying the classifying the junctions, you can also classify the specific junction as a static pocket, where you can define all the holder IDs and as well as the registers, where it can inherit from the parent, or else you can specify your own holder IDs as required. So once you have specified all these parameters, you can directly you can directly add those devices into your CAM manufacturing setup. Like you see here in the Pocket 6, I'm going to insert a tool, and I can retrieve the device from library where I have saved it. And if I say I need my newly created C4 Capto test, and I can directly, depending upon your classification of your junctions and the mounting parameters, it will mount to your turret accordingly. And then from the machining setup navigator, I can drag my tool over here, and I can mount it to the tool holder database. Now, whereas I can directly drag this assignable tool, whatever is available here, and I can drag it to my added new device. And if you see in the operation navigator under the machine tool view, now you will be seeing a lock icon over here, which basically you cannot edit or delete it inside the uh, machine tool view. These all this behavior is controlled over here in the machine setup navigator, so you can deassign it, and you can even delete this tool holder component that you have added. So all this behavior can be controlled from the machine setup configurator. Now, coming to the next topic, this is a really excited topic, I would say. NXCAM has the new face milling operation with spiral pattern and morph spiral pattern. So this update brings both powerful functionality and modern, as you saw, the intuitive user experience in the past face filling operation. So it has basically the same functionality, where you can see the changes right away when you edit inside the toolpath dialog box. You can adjust all those parameters like overhang, floor thickness, and start point, and you can see the immediate response on the graphical window. So this automatic toolpath preview is one of the standard feature, and is the automatic toolpath uh, preview as you adjust the parameters and the toolpath updates in the real time. So it basically helps to the faster generation performance. And let me show you an example inside the NX. Uh, so this is the new face mill spiral operation. You can see it inside the create operation dialog box. By the way, the little blue arrow on the top inside the create operation dialog box. So these are the new enhancements that has been introduced in the NX2506. So if I go back to my face milling spiral, as you can see, you can define this face similar to the previous face milling operation. And in the pattern type, you can see either circle, you can select, or you can go ahead and select the morph as well. And as we have the same functionality of all the all the blank containment, the thickness, the blank geometry, and the 3D IPW, we can even specify the thickness from the graphical window over here. And also we can you can even directly generate once the uh, desired output is available. So the main benefit of this operation is basically that this operation provides more smoother cutting across a regular top face, and resulting in a more consistent machining process. Whether you're cutting on a flat surface or working with more complex geometries, this feature ensures a higher quality result. So that's pretty much about the face milling with spiral, circular spiral, and morph spiral. And let's go ahead and take a look at our next enhancement. So the next enhancement is the 2D wall milling. It's another new operation that introduced the new 2D wall profiling operation designed to make the programming experience faster and easier. So there are some key benefits for this. It is easy to program with a streamlined user interface, and the new 2D wall profiling operation provides only the essential options, making it simpler to program, reducing the time and effort required. And the other benefit is the faster generation, because the new toolpath is significantly faster than the existing 2D wall profiling. So it helps you to increase the productivity and save time on each NC project that you work on. And like we saw in the face milling operation in the previous slide, this also has the toolpath preview. As you already know, it's one of the standard features for the immediate display of the toolpath preview. And as well as this operation is designed for the users who need to generate toolpaths quickly. So let's go ahead and take a look at an example. Over here, I do have a part with some open pockets and all the walls around it. So you will see the new 2D wall milling operation inside the mill planner drop down. Uh, if you see over here, there are small arrows pointing out, as I mentioned in my previous demonstration. So these are basically the new enhancements in the NX2506. So let's keep the geometry to none, and let's take a look. First, we will take a look at the 2D wall without the workpiece defined. We can specify the wall geometry, and if I go ahead and hit generate, at this point of time, there is no retraction. The clearance method is applied because we are not using the workpiece geometry. Whereas in the range definition for this specific toolpath, we can mention the extend distance for the wall top and the wall bottom as well. But make sure this does not exclude, uh, ex- this does not extends the size of more than 100% of your flute length. So it will obviously give you an error over there. So at this point you can mention and you can generate this, and as well as if you want to assign a clearance option, you can do that inside the non-cutting moves by specifying the common clearance option. You can even specify a plane, and if you generate, you will see the non-cutting moves will now retract to the specified uh, defined plane over here. So if I keep this to use inherited, and if I go back to my geometry, and if I assign a workpiece to it, and now it will adapt to the automatic clearance what we have set inside the workpiece geometry. And the other option what we have here is, if I show you, let me show this open pocket extension. You can even uh, extend the distance away from the open area. So if you see over here, we can say that we need an extend distance of maybe like a 10 mm. And if I go ahead and hit generate, it will extend the toolpath beyond the walls what we have specified. And coming to this overlap distance, I can show that in the closed pocket. You see right here, the overlap distance is around 5%. We can go ahead and extend this to 15% of the tool diameter. And once you hit the generate, you can see the difference for the overlap distance what we have mentioned. And the other option for the 2D milling operation is you can even specify the regioning for the sequence in a two different manner. The one is to define the wall geometries accordingly, like as you see here, my first set of wall is this, and the second one is this. I can even say this as my first, and this as my second, this as my third, fourth, fifth, and the fifth one. And if I go ahead and hit generate to this, the sequencing will be aligned in the sequence that I have selected my wall geometries. Or else you can even do the sequencing inside the strategy node. You can say the sequencing in a standard format, and it will calculate the toolpath accordingly. And if you say optimize, it will find the shortest form, and it will uh, create the toolpath accordingly. So the next one is for the 2D face mill mid pass. So as you know, we already have a mid pass in the previous versions, but in this enhanced face mill mid pass operation, It has the ability to create a toolpath across multiple separate faces. So now it gives you more greater control and efficiency than the previously machining individual faces required multiple operation or complex setups. But now you can simply select the multiple faces at once and organize them into machining sets, and even reorder those sets as needed. Let's go ahead and take a look at the example inside the NX. So if let me go ahead and create a operation here, and for the face mill mid pass, um, let's go ahead and select our headings over here. So now, whereas you can specify multiple surfaces, and you can even create individual sets or select all the uh, faces in a one single group. So if I go ahead and generate this, it will create all the operations in a sequential manner how I have selected the faces over here. And apart from the maintaining the sequence through the selection format, there is also a way of optimizing the region sequencing, where I think I've shown in my previous example. You can even change this region sequencing to optimize, and NX will calculate and try to give you the optimized sequence from the previous sequence what you have. So by this, you can select multiple surfaces, and you can define all the sequencing format. So that brings the uh, face mill mid pass with new enhancement to the end. And let's go ahead and take a look at our next enhancement. So let's take a closer look at the new enhancement that brings more precision and intelligence to your toolpath generation. So the ability to contain tool paths specifically to a defined machining surface. This is especially important in jobs involving castings or irregular shapes, where excess material, also known as the in-process workpiece, may exist in various locations. Uh, so not always where you're actually trying to cut, but previously NX would generate a toolpath if it detected IPW anywhere within the machining region of an operation. Uh, well, that sounds fine at first until you realize that it could include stock far away from the area you're trying to machine. But with this new functionality, you can tell NX to only create toolpaths for material that exists directly above the specified machining surface. Any IPW or a blank that's off to the side or disconnected from the machining surface area will be completely ignored. So let's take a look at the video that I have to show you for the facing zigzag.
The toolpath of face mill zigzag operations can be contained to a specified face when using blank geometry, or 3D IPW. Additionally, trim boundaries may be used to contain the toolpath in edge cases. These features can be accessed by opening a face mill zigzag operation from the Operation Navigator tree. Under Main, Containment, the blank can be set to either blank geometry or 3D IPW. For this first example, we will select blank geometry. The current blank can be visualized by navigating to Geometry and clicking on the eye icon next to Specify Blank. In this instance, the blank consists of 3 individual pieces of material. In the Containment tab, a dialog called Contain Blank 2 has been added. The user can choose between None, which is the original behavior, and Cut Area. With None selected, the tool path will generate in all places where there is blank geometry. However, the user also has the option to contain the tool path to the selected machining surface. The selected face can be visualized by clicking on the eye icon next to Specify Cut Area. After selecting Contain Blank to Cut Area and regenerating the tool path, it is now contained to just this singular cut area. Now we will show a second example for a 3D IPW workflow. For such a workflow, the blank for an operation will be based on all previous operations. While the selected cut area is identical to the first example, blank is now set to 3D IPW. Therefore, the blank, based on the two previous rotary roughing operations, looks different. Like in the first example, with Contain Blank 2 set to None, the tool path won't be contained to the cut area. However, even after selecting Contain Blank 2, Cut Area, and regenerating the tool path, it will still generate everywhere. This is because this functionality only works if the parts of the blank are completely separated. If the cut area is connected via the blank to other flat areas, NX will still try to automatically machine all areas. To overcome this limitation, the user can specify trim boundaries. This feature can be accessed by navigating to Geometry, Optional Geometry. Clicking on the icon next to Specify Trim Boundaries opens a dialog. In this example, we will set the selection method to Curves, select the edges of the cut area, and set Side Trimmed to Outside. Now, after clicking OK and regenerating the toolpath, it is contained to the specified area. Overall, with this functionality, users can easily and reliably contain toolpaths to specified machining surfaces in various cases and workflows.
So this leads to much cleaner result. NX focuses only where it should, reducing toolpath clutter and ensuring that the operation does exactly what you intended. You'll also get support for trim boundaries and the ability to set contain blank option, so either none or cut area, giving you even more control over how aggressively or selectively toolpaths are applied. It's all about aligning the software's behavior with your machining strategies. So with that being said, let's go ahead and take a look at the next enhancements that we have. Let's take a first look for the NX cam on machine probing. It's a powerful innovation in the measurement process. The machine cycle manager. You can now control the center for managing measurement cycles. This tool brings a highly visual and user-friendly approach to managing measurement workflows. You can now perform a wide range of steps graphically, which significantly reduces the setup time and simplifies even complex operations. One standard feature is the ability to create and publish your own custom cycles. This will give you the total control whether you want to optimize existing workflows or develop new measurement routines from scratch. Another key benefit is the configurable display of all cycles. That means users can tailor the interface to show only what's relevant to them, keeping things clean, simple, and efficiently. Siemens also offers customer-specific pre-assignment of parameters. This ensures that each measurement cycle starts with exactly the right setting, saving time, reducing errors, and improving the repeatability. In addition to that, the platform includes many useful references and links to relevant content, so user always have helpful resources at their fingertips. whether it's documentation, help articles, or training material. And finally, what truly sets this system apart is the precise adjustability of each individual cycle's behavior. Fine tune every step to meet the exact requirements of your production environment. In a nutshell, the Machine Cycle Manager transforms how you manage measurement processes, offering greater flexibility, efficiency, and control at every level. Now let's take a look at the major improvement in how users can select and sequence geometry points during measurement operation. For a long time, selecting existing geometry points, those defined by the design, was possible, but frankly, it was tedious, and every single point had to be handled individually, which made the process time consuming, especially when dealing with large number of points. And now with this new enhancements that has been changed and introduced an advanced selection method that makes this entire process faster and far more intuitive. Using snap function, user can quickly select multiple points from the geometry with minimal effort. Once selected, the points are automatically displayed with the numerical values that indicate the measurement order. So just to note that this functionality is currently limited to numeric, and it uses the measure function for each individual point measurement. But within that scope, the new workflow is really a game changer. Once the sequence is defined and optimized, the resulting toolpath can be validated using the toolpath animation feature, giving users a full confidence before execution. So now let's move on to some other existing usability and performance improvements that make cycle programming faster, smarter. Siemens has made extensive interface optimization. One of the most notable being the revamped lock function. Previously, lock parameter had to be unlocked before making changes. Now you can edit values directly, streamlining the workflow and reducing the unnecessary steps. Siemens also expanded support content for hexagon tool probe graphics are now included in the library examples and can be downloaded directly through the cycles package. This helps users better visualize and configure their setups. So altogether, these updates make the system more user-friendly, more efficient, and better adapted to the real-world examples, whether you're setting up a new cycle or optimizing an existing one. So coming back to the simulation and other enhancement, the rotary solution selection before there used to be a UDE rotate preferred solution and other post writer defined UDEs were used to set up a rotary axis solution in the past. Within the rotary solution selection in operation, it is easily to view and set up which solution will be used in output in the 5-axis machining. So let me show you an example in the NX of this enhancement. So here I have a part that is machined in a multi-axis motion. So if I take a look at one of the operation, so for this operation, the rotary axis is rotating towards the negative side, which is opposite side of the operator standing location. If I go to my toolpath, I can easily select the required needed tool axis rotary axis solution. It's located under the tool axis option over here. Right now, the solution is selected in A90 and C-90, whereas we can change the rotary solution from that location to the A-90 and C90. If I go ahead and generate this, and if I visualize my display tool in machine, and now the rotary axis is changed to the opposite side, whereas now in the machining side, the operator can easily see those moves, and he can be like more confident about the NC program that's been running over here. So the selected solution is like traditionally determined by the post processor previously, or an UDE, like I said. This can lead to discrepancies between the tool path animation and the final post process output. But using this functionality, I think we can easily control the solution, whatever the operator or the programmer needs. This new enhancement is related to the tangent barrel tools, which are commonly used in multi-axis. And there is a new attribute called flat diameter to the tangent barrel tool definition has been added. So this allows users to define the flat section of the tool more precisely. With this addition, the tangent barrel tools from a wide range of tool vendors are now fully supported, providing greater flexibility and compatibility in tool selection. It's important to note that as of now, NX supports tangent barrel tools with a flat diameter only in the wall finished barrels of operation. This sets the foundation for broader use in the future. So for users, the key benefit is simplified creation of tangent barrel tools, which saves time and reduces the potential for setup errors. And there is also a new supported tool type for the ISO turning tool in the Cloud Connect Tool Manager. It provides a user-friendly graphic guide, less clicks, and intuitive UI for users. If I go to my annex in the Cloud Connect Tool Manager, previous versions, the Cloud Connect Tool Manager is only supported for milling, but whereas in the 2506, you can also see the turning tools are being added. So that brings us to the end of this tech talk. While there are many more small enhancements in this release, feel free to reach out to us if you'd like a detailed demo for your organization. We'll be happy to set up a full What's New presentation tailored to your team. With that said, I'd now like to open the floor for any questions on what we have covered so far. Thank you.